In this video we are going to go through addition and subtraction of vectors together with scalar multiplication. Adding and subtracting vectors is not any harder than adding and subtracting numbers, but it is very important how it looks visually, because you have to get the idea to figure out how vectors are added or subtracted on two-dimensional shapes. So let's work through this. Now I can translate vectors from one location to another. Like I can have this vector replaced here so that they are tail to end now, and it is like going from the point 1 to point 2 and then from point 2 to point 3. So what happens if you have a shortcut from point 1 to point 3? That's the addition we're talking about. So if I call this vector as A and this vector B, this red vector, which we also call as the resultant vector, because it's the result of the operation, is nothing but A plus B. So instead of you going through point 1 to point 2 and point 2 to point 3, you directly go to point 3 from point 1. That's the addition. So now let's look at what happens when we introduce numbers, the column vectors, through this. So let's work on this now. We are going to write the column vectors. You can, if I just go through these once more, so this is the first vector and this is the second one. Right, so it starts from this point 1, 2, 3, 4 and 2. So the first vector, let me call this as A, is 4 to 2, and the second one, it's going to be 1, 2 and 1, 2, 3. So I'm going to call this one as B. This is going to be 2 to 3, right? So when I'm talking about the vectors A plus vectors B, it's going to be nothing but 4 to 2 plus 2 to 3, and what I'm talking about here is I'm going to add the top numbers and the bottom numbers separately, right? And I'm going to get nothing but 6 to 5. Well, we can check this out. Let's get rid of these and let's look at the resultant vector. So if I count from this point to this point, it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, as the column vector suggests. Subtraction is not any harder than this, so you just need to forget about subtraction. I mean, there is no such operation like subtraction. Like if we go with this vector as A and this one being B, if we're talking about A minus B, in algebra we go like A plus minus B. Now this minus B here means that I'm going to change the direction of this vector B, so it's going to be this way for minus B. So basically I'm going to go like transforming the vector B here together with changing its direction. So it's going to be minus B. So let me get rid of this. And then all I need to do is addition. So I'll go through this point to this point. That's my resultant vector, which is A. Well, we consider plus minus together as minus as shortcut. So it's going to be A minus B as the resultant vector. So when we go through column vectors, it's going to be 3 to 4 for A and minus 4 to 2 for B. Remember, the direction for B was this way. This I drew finally was minus B this way, right? So I'm going to consider this vector as given originally. So it's B. It's going to be 1, 2, 3, 4. It's minus 4 because it's left. 1, 2 up. So it's going to be 2. So if I go with the numbers, A minus B would be nothing but 3 to 4 minus 4 to 2. So basically, if I write them in one column vector, I'm going to go like 3 minus negative 4 and 4 minus 2, and I'll end up saying this is a plus over here, so it's 3 plus 4. I'm going to write down my column vector, the resultant vector, to be 7 to 2. And I can easily check it. It's going to be 1, 2, 3, 4, 5, 6, 7, and 1, 2. So, yes, this answer is correct. Now, scalar multiplication is easy. You just multiply the vector with a scalar, meaning with a number. So if I show this vector as A, if I'm talking about scalar multiplication, it's going to be K times A, as K being a number. It could be any number. It could be a fraction, right? So what we do is, now let's look at this vector. The column vector for A is 3 to 2. And if I consider, for example, K to be 2, this will become 2A. So it's going to be 2 times the column vector, right? All I do is 2 times 3, 2 times 2. So I'm going to have 6 to 4. So while doing the scalar multiplication, I don't even need to show this. I can directly write this one and go to the result. Now, usually what happens is we just extend the vector starting from the same point, but it's going to end up here. So it's going to be doubled in size, but the direction will not change. The direction changes only when K is negative. Then you're going to change the direction. It's going to be this way. Now let's consider this example. All I need to do is to substitute the column vectors for P and Q into these expressions. So it's going to be like 2 times the column vector 3 to minus 2 plus minus 4 to 1. So the order of operations apply here. I have to go with the multiplication. So I'm going to end up with 6 to negative 4 plus negative 4 to 1. And I can directly write the resultant vector. It's 6 plus minus 4. But I'm going to write down the operation bit here so that there won't be any confusions. But you may skip this step and write the answer. So it's minus 4 plus 1. The answer will be 6 minus 4, because plus and minus, I'll consider this as a minus, and minus 4 plus 1. So it's going to be 2 minus 3. That's the answer. Whereas, when I look at the second one, there are 2 scalar multiplications. So be it. I'm going to go with the substitution. So it's 3 times, now it's going to be Q minus 4 to 1 minus 4 times 3 to minus 2. So 3 times minus 4 is minus 12, 3 times 1 is 3, so this is my scalar multiplication here. Now here I suggest you consider multiplying the vector p with 4 only, leaving the minus out of it, because that's the operation, that's not the sign for the number 4 here. So let's consider this as a minus outside. 4 times 3 is 12, 4 times 3 is 12, 4 times minus 2 is minus 8, and let me write the operation bit here, minus 12 here, and 3 minus negative 8, and then the result will be minus 24, and here it's going to be 3. Well, I consider this as a plus, it's going to be 3 plus 8, so 11. Now is your turn. Work out these questions and then go back to the website, click on the online self-check and check your answers. Thank you.